Now, so here you can see from the notes over here, similar things that you have seen in the past. Okay, you will see at any stage. Okay, when you do this analysis, you need to actually show them the color change, the formation, record the formation of any precipitate, and so on. If any of the solution is warm, a boiling tube must be used. Do not use the test tube. I think it's the same thing. Please actually read on this. Okay. Now, we have FA4 and FA5 as usual. Okay, because we are doing this paper. Okay, since we are not doing the experiment, so we need to know what is FA4 and FA5. But for this case, I will reveal what is FA4 and FA5 later. Okay, I will reveal it later. But I will discuss with you, okay, what will be the observation. Let's say when you have FA4, okay, they have mentioned FA4 is a solid, okay, but it contains one cation and one anion. And then FA5 is a solution containing one cation and anion. So even though FA4, okay, when you look at it, okay, even though it's visible like maybe in powder form, maybe it's in maybe in powder form, okay, it doesn't actually indicate that this powder is going to be metal, because they already mentioned that it contains cation and anion. You need to take note of this. So don't expect when you add acid, okay, when you add acid to FA4, suddenly you are going to get hydrogen gas. Do not expect that. Okay, so all these information are very important. Now, FA5 is a solution. It contains one cation and anion. So total, we might have 4 ions over here. So here, the first one is they ask you to warm. Okay, do not boil. Okay, you are going to warm FA5 in a boiling tube. Okay, and then you stop warming FA5, add FA4 and shake the boiling tube. It means we are going to actually mix FA4 and FA5. Okay, we are going to mix the FA4 and FA5. There will be a reaction. Okay, and then what do you see when you do the experiment? Okay, when you do the experiment, so since there are two situations over here, one you actually warm, and after that you are going to mix. Okay, then after that, here they say you are going to filter the mixture into second boiling tube, and then the filtrate will be used in test in 2, which is this one. So basically, what we need to do is going to warm, and after that, we are going to mix. So what do you see? Okay, we see 2 things. Okay, you will see a blue solution is formed. Okay, this one I wrote it for you. You will see a blue solution being formed. If you see at the bottom of the test tube, okay, or the bottom of the boiling tube, you will see some kind of a red-brown solid. Okay, red-brown solid is formed. Okay, there will be red-brown solid when you mix. Okay, and then even if you actually filter, since it's solid, it's a precipitate. Okay, you can actually see a red-brown solid as the residue. Okay, you can actually see it as a residue. So according to the marking key, okay, they allow you to switch this. Okay, it means if you say red-brown solid is formed at the top, okay, and then you say blue solution is formed at the bottom, it's still correct. So, but you still need to actually mention these 2. One is blue solution and another one is red-brown solid. So 2 things, okay, when you actually mix this FA4 and FA5, you will see 2 things. One is going to be a solution, which is blue in color. Another one, you will see a precipitate, which is going to be at the bottom. But once you filter it, okay, when you get the residue is going to be a red-brown solid. Okay, take note, they are very particular about this term solid. Okay, red-brown solid. You cannot just say red-brown something is formed. So it is important to say it's a solid. Okay, or you say red-brown precipitate is formed. It's okay. Okay, or yeah, I think better precipitate or solid. Please indicate something over there. Okay, now once you actually filtrate, now for some of you who do not still get confused when we do filtration, okay, when you do the filtration, so the one that actually sticks on top, okay, and then the one that is going to come out over here, okay, this one is going to be residue. Let's not waste time by asking. This is residue, and this one is going to be the filtrate. So what they actually did over here, it means they actually took the filtrate and actually start to do this test, okay, start to do the test. And then what happened is when they actually test for aqueous ammonia, okay, when they add aqueous ammonia to the filtrate, you see a pale blue precipitate. Okay, you see a pale blue precipitate. But okay, I put it as a star over there. Okay, the reason why I put it as a star over there, because okay, when you see something that is going to be pale blue precipitate using ammonia, okay, what you need to do is, you can see over here according to the notes, okay, when you do ammonia, you see pale blue precipitate. There's only one that has blue precipitate, okay, kind of blue precipitate. It's under copper, okay, it's under copper. Okay, the rest is all different color. Okay, so when you actually react, okay, you see that, okay, there is going to be a blue precipitate, but there is going to be soluble in excess, giving dark blue solution. Now, if you see over here, it means it is important for you to add this ammonia in excess. Okay, you still need to actually go on. Okay, when you see the pale blue precipitate, you still need to add the ammonia to excess, and you will see the pale blue precipitate change into solution, means it's soluble, but it's still going to be a blue solution. Okay, once you get that, okay, you can actually do some confirmation or some kind of deduction over there, which is going to be, I can deduce that, okay, according to my notes, okay, according to my notes, it's going to be copper 2 plus. This is how I identified that the filtrate contains copper 2 plus. So I know that it contains copper 2 plus. The next, okay, the next step is going to be, you are going to add potassium iodide, okay, potassium iodide. And this one, okay, what I see, I'm going to actually see the solution, the filtrate, okay, will change into brown. So I will record, okay, it turns brown, okay, it turns brown. Then after that, they say that add sodium thiosulfate, and then I will see a white precipitate. Just record. This one is just recording. It means you do the experiment, just record. Now, what do I see over here? Maybe my deduction will be, okay, when I add potassium iodide, something turns into brown. So maybe I look at the notes, okay, something turns into brown. Maybe what, okay, see which one is brown. So probably I see that, oh, this one may be Fe3 plus, but it's actually with sodium hydroxide and ammonia. But maybe, okay, maybe Fe3 plus. So I'll just put down over there. Okay, I say maybe, okay, maybe Fe3 plus, but I don't know. Okay, I do not know, because we do not know what exactly inside. Okay, so the next step, okay, is going to be, they say that when you have the filtrate, you add nitric acid, and then you add silver nitrate. Now, the reason why we add nitric acid and after that we add silver nitrate, basically we are adding nitrate ion over there. And we know that it might, the filtrate might contain cation and anion. If you have anions such as Cl minus, Br minus, or I minus, you can refer over here as well. Okay, if you have all these three, okay, when you add, okay, with silver ions, okay, what's going to happen is it's going to give you some kind of coloration, a precipitate with different colors. Okay, chloride will give you white precipitate. That means the white precipitate is going to be silver chloride. Cream is going to be silver bromide, and then yellow is going to be silver iodide. Okay, so if you see this kind of color, which is white, cream, or yellow, so that's going to be either one of the anion over there. But what I see here is going to be, I do not see any reaction. So rather than just writing no reaction, okay, there might be reaction that is happening, but we cannot see. So please write no visible reaction, okay? Please write no visible reaction. If you see that, oh, it's still blue, and then it's not changing color when I add nitric acid and anything, no change. Please just write no visible reaction, okay? So this is important. Even though you don't see anything, don't leave it blank, okay? That is very important. Do not leave it blank. So it's actually no visible reaction. But what is my deduction based on this observation? I can deduce that, okay, the anion from this filtrate do not have these three. Cl minus, Br minus, I minus. If they have, okay, it means if those three anions are present, I'm going to actually get maybe a white precipitate, maybe a cream precipitate over here, maybe a yellow precipitate will be formed, but I don't see any visible reaction. Therefore, my deduction will be definitely not Cl minus, Br minus, and I minus. Let's go on with the next test. Okay, they actually test the filtrate. Okay, and then they add hydrochloric acid. Okay, or dilute nitric acid. It means we are going to add a dilute acid followed by barium chloride or barium nitrate. Now, if you look at the notes over here, okay, when you add barium chloride and barium nitrate, you can see that they are talking about something to do with this. Okay, HCl and HNO3, they are strong acid and it's dilute. So you can either deduce either whether it's going to be sulfate or sulfite. Okay, and what do you see over here is going to be, you will see a white precipitate. Okay, this is your observation. Now, can someone tell me, after you get this white precipitate, what is the next step that you will do? Referring to the, okay, this one is actually, the question is similar to here. I see a pale blue precipitate, then after that, the dark blue solution in excess. So now you saw a white precipitate, but what is the next step that you're supposed to actually do? Can someone help me with this? Hansen? You get a white precipitate. You know that it might be sulfate or sulfite. What is the next step that you're supposed to do?
Put it in excess dilute strong acid.
Yes, good. Okay, the acid that you have to add it in excess. See whether the white precipitate that you observe, whether they are soluble or insoluble. Okay, so when I did that experiment, when I keep on adding, I didn't see the white precipitate to be soluble. So you just say insoluble in excess. Okay, I didn't see. Okay, this one is based on my observation. It's insoluble in excess. So therefore, I confirm that it's going to be sulfate, because you see insoluble, sulfate. So here, I'm going to actually put it as sulfate. So I have identified, okay, possibility over here. I know the filtrate might have copper to plus, okay, and I know that it might have sulfate as well, okay, copper to plus and sulfate. So next step, okay, we are looking at the residue, okay, the residue. Now, do remember the residue is going to be a brown residue. Let's see, but they didn't mention. Yeah, here you know that it's actually red brown solid. Okay, and the residue, when you do the filtration, you saw that this is going to be brown residue also. Okay, it's brown residue. So if you have the brown residue, so what we did is they are adding an acid, dilute acid, and allowed to stand for 1 minute. Now, when you add the dilute acid to the residue, okay, what happened was, okay, there is a pale blue solution going to be formed. Okay, pale blue solution is going to be formed. When you add acid and suddenly it will give you pale blue solution, most likely, okay, this is most likely, most likely the only ion that is going to give you, okay, this one even without adding any OH or any ammonia, most likely if it is pale blue, most likely it must be copper 2 plus. Okay, so I put it copper 2 plus again here. And then it means the residue, when I add the nitric acid, the residue changes into copper 2 plus. Okay, changes into copper 2 plus. And then when I add aqueous sodium hydroxide, okay, it's going to actually change into pale blue precipitate. Okay, pale blue precipitate. So I look at my notes. Okay, so sodium hydroxide, when I add, it will give you a pale blue precipitate, insoluble in excess. So here, okay, when I write down over here, I still need to add another one more test, okay? Insoluble, you need to test with excess of sodium hydroxide. Is insoluble in excess. And I have this observation. So I have confirmed that both these tests is going to confirm that it's going to be copper 2 plus also in the residue. It means the residue, which is going to be the solid, okay, the solid contains, okay, ion. When we look at, they have the cation and anion. The solid, okay, contains copper 2 plus also, okay, copper 2 plus. And then the the residue contains copper 2 plus. The filtrate also contains copper 2 plus and contains SO4 2 minus based on your observation. Okay, so here from your observation suggests identity of the cation and anion present in the filtrate. So present over here, we have already identified. So copper 2 plus and SO4 2 minus. Okay, this one quite simple. Okay, so simple question actually. Okay, now write an ionic equation for one of the reaction when the precipitate is formed. Now, there's so many precipitate that is being formed over here, but let's look at the easiest answer. Okay, the easiest answer, if I see from here, will be something to do with this white precipitate. When I have, okay, we know it's sulfate. When I have barium chloride or barium nitrate, it means barium will react with the SO4 2 minus to give you barium sulfate. And by now, okay, if you are doing paper 3 with me, okay, you should know barium sulfate is very important because they give you a white precipitate. Barium sulfate is always white precipitate and it is very important. Please do remember this, okay? So this one, okay, please write it over here, which is going to be, this is the easiest one. So when you write the ionic equation, okay, this is the white precipitate. When you write the ionic equation, do remember to put the AQ over here because we are adding barium sulfate, barium nitrate aqueous, so aqueous, okay. And then sulfate is going to be, since it's a filtrate, which is going to be in solution form, so definitely going to be in aqueous form. But this one is a white precipitate, therefore must be in solid form. Now, what happens if you do not actually write down here, okay? Even though they mention over here, include state symbols. Sometimes even though they didn't say include state symbols, if you just give the correct answer without the symbols, all your symbols are wrong. You put solid to give you solid, okay? Even though everything is correct, you will get 0 mark, okay? Please take note. Okay, it must be, everything must be correct in order to get that 1 mark. Okay, next question. State the type of reaction that occurred in the first part of A3. Okay, first part of A3, this is A3. So what happened over here, okay, what I can actually suggest might happen over here is, I know it's going to be a pale blue solution. Pale blue solution is copper 2 plus. And if I have a solid, okay, if I have a solid, copper 2 plus in form of solid, okay, copper 2 plus in form of solid, generally, if you are, sorry, it's not copper 2 plus in form of solid, I'm actually getting copper 2 plus, and I know that I'm actually having something that will give me copper 2 plus. So what happened over here is I'm suspecting that, okay, this might be something to do with oxide, okay, something to do with oxide because it has a red brown solid, okay, a solid generally, maybe I can actually expect it most likely will be oxide, okay, oxide. So what happened over here when I get a pale blue solution, then after that I do this reaction, there is no such thing as like a oxidizing agent or something. So what happened generally is when I add the dilute acid reacted with my residue, which is the compound that is actually having the copper, give me a pale blue solution. It means the residue change into copper 2 plus. So my expectation, it means I'm actually thinking about copper something change into copper 2 plus, maybe copper oxide or something like that. So I'm actually maybe expecting like maybe it my expectation, yeah, maybe I might think that this is copper 1 oxide. So it might be copper 1 oxide change into copper 2 plus. So I know that there is going to be increase in oxidation number. So if the only way, maybe the best answer actually, okay, the best answer, because I'm not actually heating it up to write it as thermal decomposition. I'm not actually adding acid and base. Okay, do remember base, in this case, this is not base, okay, the residue. So it's not neutralization, okay. So the only way, I think the best answer is going to be redox reaction, okay. It's going to be changing copper plus changing into copper 2 plus. So that's the answer actually. Now, a student suggested Fa5 is acid. Okay, so one of the student actually suggested, okay, this one might be acid, Fa5. Okay, do remember earlier we start off with Fa4 and Fa5, and they are telling that, okay, the Fa4 is a solid, then Fa5 is a solution containing anion and cation. Now, so the student is suggesting that Fa5 might be acid. So it means that cation that the student is suggesting is H plus. Okay, so what you need to do to actually, let's say, apart from using indicator, do not use indicator because they're suggesting the acid. So suggest and carry out a chemical test, one chemical test to determine whether the student was correct. Now, how to test acid? So this one, maybe I'll ask someone. How do you test acid? Andrew, how do you test acid?
Blue litmus paper ya?
It's indicator. Litmus paper is still indicator. So they want chemical test. How do you test acid?
React with metal.
Okay, good. Okay, what metal? Suggest, because they say name.
Sodium ya? Or anything?
Suitable, yeah. I think
Sodium
it must be
reactive.
suitable. Too reactive. So do not actually, because acid is very reactive with sodium. So I will suggest react with magnesium. Okay, react with magnesium, metal. So you test, okay. So what is your observation and your conclusion? So I will actually say my observation. They say record, so you can just write, or you can just use a table to write all this. Observation, what you will do, okay. This one is suggest and carry out. Do remember this. You need to do the test, okay. So you are provided with the magnesium metal. So when you do, so we are expecting hydrogen gas will be released. So what is your observation? What might be the observation that you have to record over here? Imagine I'm getting a gas. So what I actually record? Let's not waste time. Okay, Alvin, what might be the observation?
Effervescence.
Good. Okay, effervescence, okay, will be seen. And then the conclusion is hydrogen gas is released. Okay, so this one is going to be acid. Fa5 is acid. Another test that you can do, okay, because they say only one, carry out a chemical test. If you want to actually do another test, okay, different test, maybe someone can suggest one more test. Maybe we'll just select Stacy Satyadi. One more test. React with what? Something that can give you gas. If you're not sure, also you can look over here.
Carbonate.
Yeah, you have to react with the name carbonate. So maybe I'll actually react with sodium carbonate. So what will you see? Your observation? Stacy?
Gas produce.
Yes, but I told you, you do not write gas is produced, yeah? Effervescence is seen, okay? Must write like this. Effervescence is seen, and then the conclusion, okay? So once you get the effervescence, you are expecting, okay? You are expecting here, I'm actually still, okay? I still need to test the gas with lighted wooden spleen. So this one, I'll get a pop sound. So here, I still need to test because it's going to be effervescence. Test with lime water. So what happened to the lime water? Okay, turns chalky, okay, turns cloudy. So the conclusion is carbon dioxide. So we can actually say Fa5 is acid also. Okay, I hope you understand how to answer this, okay. So basically, basically that's it. Okay, they didn't ask you a lot of things, but I will finish off. Okay, 901 already. I will finish off. Okay, by trying to actually summarize what we have over here. I know my filtrate. Okay, because we have copper sulfate, so this one is going to be copper sulfate. Now the residue, okay, which is the brown color, got something to do with copper. Okay, something to do with copper. So what happened over here is they didn't ask you to investigate further, and they didn't ask you what is Fa4, okay, what is Fa5, okay. But what happened over here is, okay, if you look at the answers given, okay, this is prepared for you. It's copper 1 oxide and sulfuric acid. Okay, towards the end, we have already know that this is going to be sulfuric acid. Why? Because it's going to be an acid, and then we know that it's going to be having SO4. Okay, so sulfuric acid. Now, if you just write it down over here, okay, Fa4, when you add Fa5, okay, Fa4 they have mentioned again. I forgot. Fa4 they have mentioned that it's going to be copper 1 oxide. So copper 1 oxide plus with sulfuric acid. Okay, when you add, what you are going to get? You are going to get copper sulfate. Okay, and then you are going to get water. Okay, you are going to get water. Now, when we were testing the filtrate, okay, this is going to be copper sulfate, which is the first part is we are correct, copper sulfate. Now, the second part is going to be there's no residue supposed to be, but it is just telling us that, okay, our copper 1 oxide was in excess. So it was in excess. So when it is excess, it is actually going to be at the top. Okay, so this one is copper 1 oxide excess. Okay, it's still brown. So that's why we have the residue and so on. That's why we actually put it as redox. That's why it's actually correct. So it is very important to understand this. But they didn't ask you to identify Fa4 and Fa5. Okay, but based on the observation, you need to come up with certain conclusion over here. So our aim is to get that 15 marks. Is that clear?
Yes.
Guys? Yeah?
Yes.
So I will actually put this video in YouTube. Okay, you can actually go through this again. Okay, so it's already time. I will end the lesson. See you guys.
Bye,
Bye,
sir.
sir.
Sir, thank you, sir.
Yeah.